In this video, we will solve question number 33. Option A is the additive group of real numbers. The additive group of real numbers is isomorphic to the multiplicative group of positive real numbers. Positive real numbers means R plus. Multiplicative group of positive real numbers. That means operation is dot. Okay. If these two groups are isomorphic, that means there exists a function f, its 1 1 on 2 and its f is a homomorphism. Okay, suppose fx is, I assume that fx is e to the power x. Okay, fx is a function from this to this. Okay, x came from this group R group and e to the power x is came from R plus. Okay, now we will check f is homomorphism or not. So f x1 plus x2, this operation plus came from here, plus. Okay, fx1 plus x2 equals to e to the power x1 plus x2. This equals to e to the power x1 into e to the power x2. Okay, and this equals to e to the power x1 means fx1 into fx2. Here the operation dot is came from here. Okay, came from here. Okay, that means this is homomorphism. Okay, now we will check for 1 1 and on 2. For 1 1, suppose fx1 equals to fx2. Okay, this implies fx1, fx is e to the power x, so fx1 is e to the power x1. This equals to e to the power x2. Okay, so this implies x1 equals to x2. Okay, that means this implies f is 1 1. Okay, now we will check for on 2. So for on 2, if range equals to codomain, then f is on 2. Okay, if range equals to codomain, then the function is on 2. Here codomain is R plus. Here codomain is R plus. Okay, R plus means a positive real number. Okay, so this equals to open interval 0 to infinity. Okay, and range, here range is fx equals to e to the power x. This is range. Okay, first I will draw the graph of e to the power x. This is e to the power x. Okay, if x tends to infinity, then y tends to infinity. Okay, that means range equals to upper limit of range is infinity. Okay, and if x tends to minus infinity, then y means e to the power x will tends to 0. Okay, so the lower limit of range is 0. So the range is 0 to infinity and codomain is 0 to infinity. So both are equal. That means range equals to codomain. That means f is on 2. Okay, f is 1 1 on 2 and homomorphism. So these two groups are isomorphic. Okay, so option A is correct. First option is correct. Okay, next. Option B, the multiplicative group of non-zero real numbers. Non-zero real number means R star. R star is positive and negative real numbers, but R star is not equals to 0. 0 does not belong to this group. Okay, R star and multiplicative group, this that means operation is dot, is isomorphic to the multiplicative group of non-zero multiplicative group of non-zero complex numbers, non-zero, so C star. Okay, these two groups are isomorphic or not. Now I will check. Listen, R star, here identity is 1. Okay, this is identity element, and order of identity element is 1. Okay, and order of -1 is 2, because -1 square is equals to 1. 1 is identity element, so order of -1 equals to 2. In R star comma dot, here only two finite order elements, 1 and -1. Other elements are infinite order. Okay, now in C star, 1 is identity element. Okay, order of -1 is 2. The order of identity element is 1, order of -1 is 2, and order of iota is 4, order of minus iota is 4. Okay, and order of omega is 3, because omega cube equals to 1, and order of minus omega is also equals to 3. Okay, and 1 plus iota by root 2, this is also finite order element. This order of this is 8, because 1 plus iota by root 2 whole to the power 8, this equals to, we can write this 1 plus iota by root 2 whole square and whole to the power 4, because 4 into 2 equals to 8. So this equals to 1 plus iota whole square means 2 iota by root 2 square means 2 whole to the power 4. So 2 cancel, iota to the power 4 means 1. This is identity. Okay, so in C star comma dot, there are infinite number of finite order element. Okay, and R star, there are only two finite order elements, so these two groups are never isomorphic. Okay, so option B is incorrect. Okay, so option A is correct, B is incorrect. Next, option C. In option C, it's given that the additive group of real numbers, additive group of real numbers is isomorphic to the multiplicative group of non-zero complex numbers. Okay, here in this group only one finite order element, its identity element. 0 is the only finite order element, it is identity element. Order of this is 1. Okay, and other elements are infinite order. In C star comma dot, there are infinite number of finite order elements, 1, -1, iota, minus iota, omega, minus omega. Okay, there are infinite number of finite order elements. So option C is incorrect, because these two groups are not isomorphic. In this group there are only one finite order element, and in this group there are infinite number of finite order elements. So that means these two groups are not isomorphic. So option C is incorrect, B incorrect, only option A is correct. Next, option D. The additive group of real numbers, the additive group of real numbers is isomorphic to the additive group of rational number. Okay, these two groups are never isomorphic because R is a R comma plus is a uncountable group. Okay, because in this group there are uncountable number of elements. Cardinal number of this group is uncountable, and cardinal number of this group is countable, because Q means rational number, is a countable set. Okay, so cardinal number of this group is countable and cardinal number of this group is uncountable. That means these two groups are never isomorphic. So option D is incorrect. Okay, option D incorrect, C incorrect, B incorrect, only A is correct. So the correct option is option A. Okay.